What is up, everybody? So we are doing dilation. Now, dilation, if we were looking in the book, is actually in chapter 7, but we throw it into unit 3. So this will be 3.4 dilation. Now let's think of all the previous transformations that we've done. We've done reflection, translation, and rotation. Now for all of those transformations, our figure has not changed shape or size whatsoever, right? We call that isometric transformations. With dilation, though, our figure is going to either get bigger or smaller. Just like when you think of the word dilate, right? Most people think of it as getting your eyes dilated, or your eyes are dilating, right? When you go into a room that is dark, your eyes dilate, get bigger to let in more light. Or if you're in a dark room going into a room with more light, your pupils will shrink to protect your eyes from all the light that's happening, to absorb less light. So your pupils are getting smaller or bigger, aka dilating. So dilation is the process of enlarging or reducing a figure proportionally with respect to a center point based off a scale factor. Now, when we dilate, what you have to understand is we're not just making something bigger. We're making smaller. We're making something bigger or smaller based off what is called a scale factor. So what the scale factor determines is how much bigger or how much smaller we are making our figure. But it's also important because every single side of our figure has to either increase or decrease by the same amount. We call that keeping it proportional. If I was to increase some sides more than others, that would mess up the proportions and the figure would no longer be the same shape. So we still want it to be the same shape, we just want it to be a different size. So that is why the scale factor is such a big thing, because it determines how much bigger or smaller every side is going to get. So as I just got done talking about the scale factor, that's what determines how much bigger or smaller, or we call that enlargement or reduction. The capital letter K is usually used to determine scale factor or represent scale factor, so that's the variable. And if K is greater than 1, then you're going to have enlargement. So if your scale factor is bigger than 1, your figure is going to be getting bigger. If your K is less than 1, then that is reduction. Now K will never be 0, K will never be negative. So it will always be between 0 and less than 1 if it's reduction, or greater than 1 if it's enlargement. Now what you'll find is that scale factor gets out of hand really quick. So when you say, well, I want to make something 3 times bigger, that's going to make it way bigger. Or if you want to make something 1/3 smaller, that's going to shrink it really fast. So we're not going to have any crazy K numbers, because what you'll see when we start graphing, the images start getting bigger and the graphs start getting a lot bigger. So we keep it usually between like 1/2, 1/3, and like 2 or 3. Like we'll rarely ever have a scale factor of 4, because then your figure gets really big really fast. So there's 2 types of dilation. We're going to learn one today and one in the next video. So you can dilate from the point 0, 0. So just like when we did rotation, how we could rotate around 0, 0 or rotate around a point other than 0, 0, the same thing is true with dilation. So you can dilate also from a point other than the origin. So we're only covering dilating from 0, 0 today. We'll cover dilating from a point other than 0, 0 at a different time. But the outline for the notes is going to be the exact same. So you can just print this whole thing out and you'll be good to go. You don't have to print out another one. Okay? So just one more quick review before we move on. So dilation is enlarging or reducing a figure. Dilation is determined by the scale factor. As long as you increase every side or decrease every side by the scale factor, then your figure will keep its proportion. If you don't do that, then it loses its shape and it's no longer a dilation, right? You're just changing it altogether. And then for us today, our center of dilation is going to be at 0, 0. So go ahead and pause the video if you haven't printed out the outline and copy down this graph. You have 3 points, A, B, C, making up that triangle. A is at 2, 2, B is at 2, 4, and C is at 6, 2. All right, so let's get into this. So first thing we're going to do is we're going to dilate with a scale factor of 2. Now it's very important to understand that, remember, we're dilating from the point 0, 0. So what you need to know is that our figure is going to be expanding in this direction, and if we reduce it, it's going to stay within those parameters. So what I mean by that is if I were to draw in a line from 0, 0 through B, and if I kept it straight through A and through C, in theory, if I were to enlarge it or reduce it, all my B's should be on this line, whether it's enlargement or reduction. All my A's should be on this line, somewhere on there, and all my C's would be on this line. And so it kind of creates this three-dimensional effect where it would shrink down all the way into here, or it could enlarge all the way to here. Now, obviously, those locations are going to be very important because I can't have a B up here and an A down here and a C over here. See how that all of a sudden no longer really resembles what this blue triangle looks like? So the exact location of where they would be does matter. I can't just put a B here, an A here, and a C here and say, oh, they're going to be similar. But I'm just telling you that's the path that they're going to travel as we either enlarge or reduce. And I'll show you when we're all done. It's really kind of cool looking once you do it. So I'm going to get rid of those lines for right now. We'll see if that stays true. So here's how dilation works. It's actually really easy. Pretty much is one of the top 2 easiest transformations. So if my scale factor is 2, what I'm going to do is I'm going to multiply every single x and y coordinate by my scale factor. So there it is, as in a rule format, xy becomes 2x, 2y. So all this is saying is I'm going to multiply every x value and every y value by 2. And that's how you keep the proportion, right? Like if you're increasing everything by the same amount or decreasing everything by the same amount, the figure should keep its shape. So here's what that looks like. So A is at 2, 2. So A prime is at 4, 4. Again, all I did was multiply my x and my y by my scale factor. B is at 2, 4. So then that means that B prime should be at 4, 8. And then C is at 6, 2. So then C prime should be at 12, 4. So again, guys, all we did was multiply every x value and every y value for A, B, and C by 2. Let's go ahead and plot those now. Okay, so again, I went over 4 and up 4. Get my A prime. I went over 4 and up 8 to get my B prime. I went over 12 and up 4 to get my C prime. Now notice how far it's already past my little graph that I made. Go ahead and connect them up. Now remember what I showed you. Those two B's, if I make a straight line, they should be together, and look at that. And the A's as well, and the C's. Okay, it looks really cool when you have multiple, more than 2. So let's do a reduction now. Okay, with a scale factor of 1/2. The same rule applies. So let's use the same points, A, B, and C, but now our scale factor is 1/2, which means that is a reduction, which means our shape should now be getting smaller. Okay? So all I have to do is multiply every single point by 1/2, aka divide it by 2, and that's going to give me my new locations of my points. All right. So 2 and 2 times 1/2, that becomes 1 and 1. 2 and 4 times 1/2 becomes 1 and 2. And then 6 and 2 times 1/2, or divided by 2, is 3 and 1. Let's plot those. Now, I'm using the same A prime, B prime, C prime because I'm not dilating. So just please understand, I'm not doing the same transformation from this point right here. So just understand that these are separate answers, okay, and that they're not related. Let's go ahead and plot them out. Go ahead and connect them. Now let's draw our lines. And so here's what I meant where it kind of looks cool. Notice that all the B's are on the same line. All the A's are on the same line. And all the C's are on the same line. So you can see I can go all the way down to like 1/99 reduction, or I could do 99 scale factor enlargement, and it would still stay in these parameters. So it goes all the way down until eventually I would get so close to 0, 0 that we couldn't even see it, right? And so it's almost like that triangle's on a path where it's like traveling towards you, right? It's got that three-dimensional look where bigger and bigger and bigger and bigger and bigger until it'd be like right in your face, okay? And so again, big takeaway here is to do dilation, all you have to do is multiply the coordinates, A, B, and C, by whatever the scale factor is. And that's it. Okay? Video done. Next video, we'll talk about dialing from a point other than 0, 0.